Hello boys and girls, it is Mr. Malzberger here. Time for Unit 7, Lesson 5, Pythagorean Theorem. This is one of the most important lessons of this entire unit because the Pythagorean Theorem has to do with triangles, and math people love to use it because it incorporates geometry and algebraic equations. You have to square things and you have to root things. And so there's all these cool patterns with right triangles. And that's what we're going to look at. So here we go. Pythagorean Theorem. That's the only way I can remember how to spell some of these things. Okay, so there's a guy in ancient Greece, Pythagoras, and he started looking at right triangles. Of course, you know right triangles are right because they have a 90-degree angle in them. So this is a pattern with side lengths on right triangles. That's what this is. That's all this is he noticed there was patterns and he was able to make a rule that works every time. So first off, you have these two sides of a right triangle that make up the 90-degree angle. They are known as the legs. That's important because the legs always end up on the same side of the equation. The other side over here is the hypotenuse. Let me say it right. Hypotenuse. If you heard me spell out Pythagorean Theorem, which is the only way I can remember how to spell this, I have the same kind of thing for hypotenuse. It's hy, H-Y this time, pot, and use, N-use. Hypotenuse, high, pot, and use. It's my way of breaking down into 4 parts and a little phrase to remember how to spell that stupid thing. So those are the two distinct sides of the equation. The hypotenuse, always the longest side of the right triangle, is on one side of the Pythagorean theorem, and the legs are always on the other side together. Now, they're interchangeable. The variables we use to represent them are a and b, and the hypotenuse is always c, c being the largest side, longest length. The formula is a squared plus b squared equals c squared. So if you take the length of a and square it, all right, make it a square, and then you add to it the square of b, their value will equal the square of c. Let me give you an example, and then I'll show you the pattern to solve these. It's always the same thing with one variation. That's it. And the variation, either you add or you subtract. I'll show you. Here we go. Actually, sorry, there's 2 variations, but it's only in the answer for the other one. So let's say I have this right triangle, and I'm going to give you one. Oh God, that's horrible. That's so curved. Let's say 3 meters and 4 meters, and we're gonna find the hypotenuse. Okay. So how we do this is we plug this into this pattern that Pythagoras found, that if you square both legs and add them together, they equal the hypotenuse squared. So first thing you need to do is you need to find the square. You need to find the square because the two sides that make the square are the legs, and they have to go in the A and B spot. It doesn't matter. It can be 3 and 4 or 4 and 3. And whatever you have for the hypotenuse is going to go there, whether it's a number. It can be a number, of course, or it can be a variable. So that's the first step. find your hypotenuse, find your square, find the two legs, make sure they're on the same side, opposite the hypotenuse. Next step, we're going to square everything. Everything gets squared, matching the formula. Now we just work it out, and it's a simple equation. Math teachers love this because it forces you to square things, it forces you to solve like an equation, and it forces you to root. So numerical bases, of course, we're actually going to square. So 3 squared is 9, 4 squared is 16. The variable just sits and waits is what we're going to solve for. Then we add. If I give you the two legs, you're going to add. If I give you the hypotenuse in one leg, this is the x, well then you're going to subtract every time. So legs given, add. One leg given, subtract. That's the other pattern, and I'll show you with another example. All right, so 9 and 16, they add up to be 25, and you'll say, hey, that's a perfect square. So when we take the square root of both sides, because I'm taking really the square root of the entire equation, the square root of 25 is 5, the square root of c squared is c. Now if you say, wait a second, doesn't every square root have two answers, both a positive and a negative? You'd be correct if it's numerically just a number being rooted. But when we talk about geometry, there's no negative side lengths, so therefore you have one positive answer, and that's it. Let's do another one. All right, so let's make this one where we look for another side. We're going to look for one of the legs. So I'll give you this leg here, say 12 centimeters, and this leg will be 13 centimeters, and then we've got, I'll just call him x down here. Okay, we're going to follow the exact same pattern. It's going to be the a squared plus b squared equals c squared pattern. First thing we do is find that square, which I didn't write down. Once you get the square, you're going to say, well, these two lines that make this square are my legs. They have to be on the same side. So it's going to be 12 plus x equals whatever the hypotenuse is, 13. And then we're going to square everything, right? Square, square, square. Numerical bases, I'm going to square and actually create the number. 12 squared is 144. X squared stays. 13 times 13 is 169. And so up here, I gave you the two legs, so we added. Here, I gave you one leg in the hypotenuse. You subtract every time this happens. It's a one-step equation right there, basically. Even though this is, what is this, a three-step? Maybe. Right? So I get x squared equals, what's that going to be? That's going to be 25. What? Again. And so we square root, and I get x equals 5. Crazy, right? So these are, these two right here are called Pythagorean triples. And like perfect squares, they're numbers that fall in the number line pattern where their roots are whole numbers, right? Everything in between, you have an irrational number, but these perfect squares, you get whole number answers. These are the sum of, there's a ton of them, perfect right triangles where each side length is actually a whole number. 3, 4, 5, right? So 9 plus 16 equals 25. That's what we're looking at here. Now this is the most common one you're going to see, but they never give you this exact version of it because 3, 4, 5 is the first one everyone learns. It's the most common one, so they give you a variation. So they're going to enlarge it. They're going to double it or triple it or quadruple it. They are taking this and transforming it by a scale factor of 2 or a scale factor of 3. Remember from back in geometry back in the first semester? So you're never going to see 3, 4, and 5. You might see 6, 8, and 10 though. 36, plus 64 equals 100. See how that works? And then again, they could, this is a scale factor of 2. Let's do a scale factor of 3 and get 9, 12, and 15. 9 squared is 81, and 81 plus 144 equals 225. So you're never going to see 3, 4, 5, but you're going to see versions of it. They'll give you the 5, of course, because that's an easy one too. 15, 20, and 25. That's going to be 225 plus 400 equals 625. These three right here are the things you're going to see the most. Now, there's another one, and I gave it to you right here. This is another Pythagorean triple that they use a lot. 5, 12, and 13. The reason why this gets so much used is because I get actually 2 scale factor of 1 and a double that I can use there within reasonable squares. You know, we're in the 20s and 30s and not looking at things in the 58s and the 60s. Those are bigger numbers and harder sometimes for kids to do. So you see these are within a reasonable range. So this, its scale factor of 2 would be 10, 24, and 26. And you may see a 15, 36, 39, but nothing much larger than that. This and this. This one, very, very used. This one not very much, but these 2 and these 3. And that's your learning one, right? And the other one is 8, 15, 17. You rarely see it's double because it's... Okay, sorry. Ran out of storage on my phone. So anyways, here we are. These are the Pythagorean triples, again, to recap. The 3, 4, 5, the 5, 12, 13, and the 8, 15, 17. There are tons of other ones. But these are the ones you're going to see, okay? Now, there is the question of what happens if I don't get a perfect triple? What happens if I get a right triangle with sides that don't match up so well? Let's say 9 meters and 14 meters, right? And we're solving for the hypotenuse. What do we do then? It's pretty simple. Follow the exact same pattern. Find the right angle. Say, okay, these 2 are the legs. They go on the same side together. Hypotenuse goes on the opposite side. Everybody gets squared. Square your numerical bases. 81 plus 196. That's x squared. And now we add these up, and that's going to be 277 equals x squared. And you take the square root of x squared and 277. Now, of course, I would like you to think, oh, can I divide this by any perfect square and simplify it? Well, it's not divisible by 9. And it's not divisible by anything, really, that I can see, because it's not. 14 plus 2 is 16, so it's not divisible by 3 or 2. It's not divisible by 7. No, because that would be 67. No. So this is that. That's it. All right. There are ones that, of course, I'm sure we could find. Let's do something. These are pretty ugly looking. Let's do like 4 inches and 8 inches, right? That's going to give us something that we can simplify. So if it doesn't look like it simplifies, this is your answer. It's just the square root of 277 is what x is. Boom. This one, let's do the same exact pattern. There's my right angle. There's my 2 legs. 4 plus 8 equals x. Everybody square. I get 16 plus 64 equals x squared. Add these 2 up because they're on the same side. I get 70, 80 equals x squared. And now I'm going to take that square root. And I can see that, well, I know that 80 is divisible by 2. It's also divisible by 4. So I got 4 times 20, right? I say, well, I can then split 20 into 4 times 5. So I can really split this into 16 times 5. So I could simplify this by pulling out the 4. Remember, like we did in the imperfect squares lesson, leaving the 5 behind. So you could do that. I'll probably throw one of those in on the test, on one of these triangle ones. Does that make sense? You want to do one more? Sure. Now, of course, oh my God, that's the worst hypotenuse ever. Just terrible. I can't even make it acceptable. I'm so sorry. Let's do 6 and 9. 6 feet, 9 feet. My thing doesn't even work well. Or let's get crazy and let's make an X here and let's put like 12 here and see what happens. 12 feet, right? So there's my square. There's my 2 legs. 6 plus X is going to equal 12. Square everything. I get 36 plus X squared equals 144. I need to subtract because they're not on the same side. I get X squared equals 108. I'm going to square root everything. Now 108 is a multiple, I know, because it's 12 times 9, right? I've got 12 times 9. Well, right here, there's a perfect square, right? 9 is a perfect square. And then I'm going to split that 12 into 4 and 3, and there's another perfect square. So for this one, I get X equals, this is the only guy who's not a perfect square. He's going to stay inside the radical sign. He's just going to sit there. What I'm going to pull out is the square root of 9, which is 3, and the square root of 4, which is 2, and I'm pulling out a 6. If you're ever curious if you mess this up, square this. 6 squared is 36, right? And then multiply it by that. 36 times 3 is 108. You're good. Okay, so how about we do the practice? You got 6 problems on there to do. So pause the video, take care of those, and then we'll go over them. And here we are. We're back for Pythagorean theorem practice. Let's just get it going. Number 1, there's my square. Those are my 2 legs. So I've got 5 plus 12 is going to equal C. I square everything. I get 25 plus 144 is going to equal C squared. Add these 2 together, I get 169 equals C squared. Take that square root. I know that is a perfect square. It is 13. And there's my 5, 12, 13 Pythagorean triple. Let's come over to 2. I've got a square here. These are my 2 legs. So I've got 12 squared plus 16 squared equals X squared. Yes, you can do that in one fluid step if you want to. You don't have to do 12 plus 16 plus X and square. Let's square everything though. That's 144. That's gonna be 256. Okay, and if I add these up, that's 300, that's 400. Okay, so square root of 400, that's pretty easy, that's 20. Boom. Now, if you notice, 12 and 16 are both multiples of 4, right? So if I divided 12 by 4, I get 3. And if I divided 16 by 4, I got 4. So you could already know this is a 3, 4, 5 triangle that has got a scale factor of 4, so you'd know that's 20. Makes it a lot easier to know the answer before you start. Number 3. Once again, I've got both legs because there's my square. So I've got 7 squared plus 9 squared equals the hypotenuse, X squared. So I've got 49 plus 9 squared is 81. That equals X squared. So 9 plus 81 makes 90, and 90 plus 40 is 130. Take the square root of that. And that's just 13 times 10. And so there's nothing I can do. So this is just x equals the square root of 130. Coming on to number 4. I've got, here's my square, so there's my legs. So I've got 8 and x, and they're squared. They're going to equal 10 squared. That's 64. So x squared equals 100. Different sides, so I'm going to subtract. I get x squared equals, that's 6, that's 36. Square root everything, I get x equals 6. Okay, last two, here we go. Number 5, there's my square, so those are my legs. So I've got 10 squared plus 12 squared. It's going to equal nothing squared. I didn't put anything there. Hope you picked X or a W or a Z or whatever letter you liked. That's going to be 100 right there, plus 144 equals X squared. Add those up, you get 244. And now we're going to square root it. Wow. I can see, because 24 is divisible by 4, and so it's 4, that I could divide by 4. So that's going to be 61. Right? 4 times 61. 61 is a prime number as far as I know. So I think this is just going to be the square of 4, which is 2, times the square root of 61. Yay. Last one. Here we go. There's my square. I got x and 24 as my legs. So 24 squared plus x squared is going to equal 26 squared. I know 24 squared is 576 because I know that. You might need a calculator for that. 26 squared, I also know is 676. I know that. And this is why. Because this is the 5, 12, 13 triangle that has been dilated by a scale factor of 2. And when you subtract this, get x squared equals 100, and you say, yay, it's a perfect square, so x must equal 10. So the 10, 24, 26, that's the 5, 12, 13 doubled. So that's the Pythagorean theorem practice. You now have homework number 9, 6 more problems just like this. You're gonna have probably 2 that don't work out perfectly. Good luck with that, and have a great rest of your week.